a fun activity that allows students to create their very own pet photons and will allow them to explore photons across the entire electromagnetic spectrum. To get started, student will need some simple material, pipe cleaners and plasticines in 4 different colors: blue, green, red and black. Black color photons represent infrared photons coming from warm objects. Each color will help us understand different aspects of visible and invisible photons. As you know, light comes in the form of photons. Most of these photons are invisible and can be found emanating from everyday things like phones or hot objects. The crucial thing about photons, which was discovered by Einstein, is that they exhibit both wave-like and particle-like characteristics. In Einstein first, we use the terms waviness for wave-like characteristics and bulletiness for particle-like attributes, which include momentum and ability to push things. We describe this to students by the phrase everything has bulletiness and everything has waviness. The reason we say everything has waviness and bulletiness because these two are not confined to photons only. It applies to atoms, molecules, and even large objects like mirrors in the gravitational wave detectors that exhibit a tiny bit of waviness. Bulletiness and waviness are inseparable. Students can work in groups of 4, with each student choosing to create one color of photon and then write its properties. For example, a student making a red color photon can note its wavelength as 650 nanometer. Each group will need red, green, blue and black pipe cleaners as well as plasticine. Now let's make a red photon. Choose a red pipe cleaner and a red blob of plasticine. The pipe cleaner needs to be bent up like this. So this is waviness, the distance between peak its wavelength, the distance between two peaks or two valleys. The size of the plasticine ball represents its bulletiness, its momentum, its ability to push things and break things. Photons have 4 important properties that are all related. Their wavelength that we have just seen, their frequency, how fast the waves go up and down. Shorter wavelength means higher frequency. Then there is a momentum. And finally, their energy. Energy is given by its simple formula in physics. Energy equals the quantum constant times the frequency. Now let's make a blue photon. Blue photons have round about half the wavelength of red photons, which means they have nearly double the frequency and double the momentum. So we have to use a big blob of blue plasticine. So you can see here. Green is in between red and blue. Its wavelength is about 500 nanometers. So I'm making a green photon now. So here is my waviness part and now I'm attaching a blob of plasticine. So this is our green photon. Our black photon represents the invisible photons that we feel as warmth. Any wavelength from a bit longer than the red photon up to 20 times longer is infrared photons. Okay, so this is our black photon. Now the students are ready to display a spectrum. They could lay them on a table or all line up for a group photo with the photons clearly arranged in order of wavelength from infrared at the bottom and the blue on the upper side. Students could vote for the best photon. It's a bit tricky to make the wavy section. Now it's time for some important discussion. First, note that our PET photons have separate wavy and bullety part. In real photons, they can never be separated. Second, why did we stop at blue? There are plenty more. The whole range is called electromagnetic spectrum, like this one. Third point, how big are real photons? Well, our PET photons are 10,000 times bigger than red and blue photons. But radio photons have huge wavelength that can be meters in size. How does the waviness and bulletiness vary across the spectrum? This room is filled with radio photons from our phones. They have a wavelength of 30 centimeter and are a million times less bulletty than light. So their bulletiness is hardly detectable. That's why we call them radio waves. On the other end of spectrum, X-rays and gamma rays have much shorter wavelengths. Gamma rays are part of dangerous radioactivity that can be very harmful because they are enormously bulletty. They can smash atoms with ease. And the X-ray can go right through us, but they also cause damage on the way. So radiographers have to be very careful. Gamma rays are millions of times more bulletty than visible photons. You would need a house-sized lump of plasticine to make a PET gamma ray photon. Finally, let's discuss why UV photons are harmful, as they have more bulletiness and can damage our DNA molecules, potentially causing skin cancer. On the other hand, microwaves are more like radio waves. They can make molecules jiggle. That's how microwave oven heat things up, but they do not have the bulletiness needed to break molecules. If you have time for one more activity, students could make some toy atoms out of balloons and throw their pet photons at the balloon to see if the more bulletty photons make the balloon move faster.